Hello everyone. In last session we have discussed what is decision tree. Now in this session we are going to discuss how to build a decision tree or how to construct a decision tree. Now suppose this is the data set given which consists of four attributes: age, competition, type and profit, and some entries are given in that database. So first of all what we have to do over here, so we have to find out the target attribute from this data set. So whatever the data set you have to choose the attribute which is to be considered as a target attribute. So here we are using profit as the target attribute. Target attribute, we also called it as a class attribute. So from which we are going to identify the class, right? So here profit attribute we are considering as the target attribute. So once that target attribute is fixed, so next what we have to find out, that is we have to find out the information gain of that target attribute. Now what is this information gain? This is the one of the impurity measure of decision tree, which is very helpful to build this decision tree. So there are various impurity measures of decision tree like information gain, Gini index, entropy. So here we are using information gain and entropy concept to build a decision tree. Okay, so first of all, we have to find out the information gain of the target variable. Now this can be calculated as minus p divided by p plus n log 2 p divided by p plus n minus n divided by p plus n log 2 n divided by p plus n. What is this p and n that we will see afterwards? Okay. Now next, this information gain we have to calculate for the target attribute. Now what about the other attributes? So for the remaining attributes we have to find out the entropy for the remaining attributes. Okay. Now to find the entropy of the remaining attribute, this is the formula to find out that entropy. So entropy of a particular attribute is equals to summation of I is equals to 1 to n, pi plus ni divided by p plus n information of pi and I. Now in simply, what is the information, what is the entropy? That is the information gain multiplied by probability. So information gain of these two multiplied by the probability of these two. Okay, now what is that p and n that we are looking next? Okay, now after finding that after finding the entropy of each and every attribute present, we have to find out the gain of that attribute also. Now to find out the gain of that particular attribute, the formula is gain is equals to information gain minus the entropy of that particular attribute. Now this information gain is the information gain of the target attribute that we have to consider minus the entropy that we have calculated over here for the particular attribute. So uh, so first of all we will find out then the information gain of the target attribute. Okay, now the here we are finding the information gain of the target attribute. So information gain is equals to minus, we are taking common, minus of 5 by 10. Now what is the meaning of this 5 by 10? This is nothing but that p divided by p plus n. So here, so p is nothing but, here we have mentioned p is the down and n we are representing for the up in the class label. So p means what? Down. So how many times down appears over here in the database for the profit variable? The 5 times. So that 5 comes over here. So 5 divided by p plus n. So what is the value of n then over here? 5, right? So 5 plus 5, that is 10. Or we can consider the total entries in that database. Okay, so 5 divided by 10, clear? So log 2 5 divided by 10 plus n divided by p plus n. So n, here the value of n is also 5. So 5 divided by 10 log 2 5 divided by 10. Now this we are going to solve. So is equals to 0.5 log 2, we know that 1 by 2 we can represent with 2 raised to power minus 1. So likewise we have represented over here. Now minus 1 we are taking common over here. Here when we consider the minus 1 common, so this comes like this: minus 1 log to 2 minus 1 log to 2. So this is nothing but the 0.5 value. Okay, so minus 0.5, this is nothing but 1. Log 2 means what? 1, right? Log 2 means, sorry, minus 1. So minus becomes, sorry, log 2 means 1, so it's nothing but the minus. So minus 0.5 minus 0.5, it becomes 1. So information gain for the target attribute that we are getting as 1. Okay. Now, once we get the information gain of the target attribute, we have to find out the entropy of the remaining attributes. Now here we'll find out the entropy of each and every attribute. So we are having three attributes. So first attribute that we are considering, that is the age. Now, while finding the entropy of this particular attribute, we have to consider this type of we can consider, or we can build this type of table. That is, we have to consider the possible outcome and the different variants. So different variants are down and up of the target variable, right? So what are the different possible outcome of the age? So age, old, mid and new. These are the three possible outcomes, right? So here that we have considered old, mid and new. Now down, for down, how many old are there, that we have to find out. So if we consider age old and profit as down, so 1, old 2, old 3. So how many times? 3 times. So 3. So now same for old as up. Old as up, there is no element present in the database. So that's why that value becomes 0. Same we have to find out for the mid. So for mid, 2 up and 2 down, right? Same for new, 3 ups and 0 down. So that we have constructed the table like this. So now we have to find out the information on gain of each and every possible outcome. Now what is that? So information gain of this old, first we are finding out information gain of that particular attribute, that is old. So how we can find out this? That is 3 minus common we are taking. So 3 divided by 3. Now what is the meaning of 3? 3 is the down time. 3 is the value of down that is appear over here in the table, and divided by 3 means what? How many times that old attribute appears in the database. So 3 times it is appeared, that is that's why it is 3 by 3. Yeah? So log to 3 by 3 plus same for up attribute 0 is there, so 0 by 3 log to 0 by 3. So its value becomes 0. So 0 multiplied by, now we have to find out the information gain, right? Or the entropy for this attribute. So entropy for this attribute is nothing but the information gain multiplied by the probability, right? So information gain that we have find it, that is 0, and multiplied by probability is, so probability is what? How many elements are present in the database, that is 10, and old how many times appear, that is 3. So that's why 3 by 10, but it's become 0. Same we have to find out for the mid attribute. So mid attribute is equals to minus, now here for downtime it appears 2 divided by 4. Now mid appears 4 times in the database, that is the value becomes over here divided by 4. Log to 2 by 4 plus same for up, the value is 2 in the table. So 2 by 4 log to 2 by 4, it becomes the value as 1. So this is the information gain, that is 1 multiplied by the probability. How many times appear mid in the database, that is 4 divided by 10. So value becomes 0.4. Same we are finding for the new attribute. So information gain for new attribute is equals to 0 divided by new appears in the database 3 times. That's why 0 divided by 3 log 2, and this becomes 0 multiplied by 3 by 10, that is 0. So now if you can see, we have to add this all three, that is it becomes 0.4 only. Now we have to find out the gain of that particular attribute. So gain is equals to what? Information gain of target attribute minus the entropy, right? So what is the information gain of target attribute that we have calculated as 1, right? Minus what is the entropy? So we have to add all these three. So it becomes 0.4. So information gain becomes 0.6. So same entropy we have to find out for the other two attributes, that is computation. So here we have shown in the table. So there are two possible outcomes in the computation in the table if we consider yes and no. So we have to find out that table first, then the information gain of that particular attribute, or we can say the sub attribute. Yes, it becomes whatever it becomes multiplied by the probability, right? So gain becomes 1 minus whatever it appears is equals to 0.124. Same we have to find out for the gain of type variable, it becomes 0. So we are having gain of age that is 0.60, gain of competition as 0.124, and gain of type is equals to 0. I don't have calculator right now, that's why I have not calculated these values. You can calculate it. Okay. Now, so see here, this is what we have to consider. Now after that, initially we have considered the information gain of the target variable as 1. Now we have to, from this remaining three attributes, that is type, age, and the competition, or the age, competition, and the type, we have to consider the root attribute. Now, which is the root attribute that we have to consider from this three? That is what whoever having the highest gain, that is considered as the root attribute of the decision tree, right? So which attribute is having the highest gain? That is age, that is 0.60. So age we are considering as the root attribute for our decision. So uh, age we have considered as the root attribute. Now it is divided into three because there are three possible outcomes that we have considered: old, mid, and new. Now here if we see, for old we have shown down, for new we have shown up, but for mid we have included the new node. Now how it becomes? Now see here in the database, if you consider age as old, so for all three, how many times it appears? 3 times. So for all three old age, the profit value becomes down. Same value is there. That's why we have mentioned over here the down. Clear? Same if you consider the new, for all three new, the profit value becomes up, right? So here, that's why for new we have considered the up. But if you consider the mid, so for mid, for two attributes the profit value becomes down, and for two attribute it becomes up, right? So in the cases where for some attribute it's having different value and for some attributes it's having different value, there we have to consider the next node, or there we have to consider the next. So when some are with the up and some are with the down, then we have to consider the next node. Okay. Now next node, same, while considering the next node or the next attribute as the node, we have to same consider as the highest, which is the next highest gain for that particular attribute is competition is the next, because type is 0, so 0.0124 is the next attribute. So that's why next attribute that we have considered as the competition. Now competition having two possible outcomes, yes and no. Now if we consider same, we have to find out in the table. For yes attributes we are showing down, and for no attributes we are showing up. Now how we have calculated same? If we consider competition, yes, so for uh, competition with the yes value, it's showing down, right? Yes, down, yes, down. Clear? Now same The competition with the no attributes, maximum it's showing, right? So that's why if we are considering it as the up value, right? So this is the final decision tree. Here no attribute comes with the different values, so that's why no next splitting will be considered or no next attribute will be considered. If here some attribute or some value will be considered, as if we consider the yes, for the competition with yes is some with the downtime and some with the uptime, then at that time you have to consider for the next attribute, that is the type attribute, but here we don't have to consider that. So here is the final decision tree for your given data set. So this is the most important question that is asked in the examination, and this is the most likable question of particular examiner to be considered in the exam. So thank you very much.